Hi, everyone. I'm Kfir Bar. I'm the Chief Scientist at Basis Technology, and thank you so much for joining this session. My plan for this session is to cover some topics related to how natural language processing is used for diagnosis of mental health disorders. I will begin by explaining how NLP is related to mental health and then show you some results of a study that I've been working on recently about detecting schizophrenia using natural language processing. Okay, so let's start with this. Natural language processing is all about processing text. The input is text, obviously, completely unstructured, and the output could be either structured, as in the case of sentiment analysis, or unstructured, as in the case of machine translation. So in the last several years, people have been exploring different ideas for using computational tools to process human language for detecting mental health disorders ahead of time, as well as providing treatments using those algorithms. And here in this session, I will focus more on the diagnosis part. Mental health disorder is an illness that affects the way a person thinks, feels, behaves. It's a major disease, and according to the CDC, up to 1 in 5 children in the United States experience mental health disorder every year. And there are many types of mental health disorders, as you probably know. Some known categories are here: depression, schizophrenia, bipolar disorder, PTSD, which is post-traumatic syndrome disorder, and more. The language that we speak reflects how we feel and think, and it is often analyzed by clinicians and mental health professionals to diagnose mental health disorders, as well as to provide treatments when needed. And natural language processing is the technology we use to process written text, like text that we write on social media, for example, or transcriptions of speech. Processing the audio signal of speech is also relevant for mental health applications, typically focusing on prosody, which is a collective definition for intonation, tone, stress, and rhythm. Clinicians and data science researchers have been doing this analysis for many years now, looking at different levels of the language, using various computational tools. One of the most popular analysis is done on the word level, simply by counting the number of times words of specific category appear in the text, which could be something that you wrote, like on social media, or in transcription of what you said. So, for example, how many positive words were mentioned by the speaker, right? So that definitely can be a good indication for detecting depression or signs of depression. Now, the counting can be done on different linguistic forms of the word, like the surface form, basically just the word itself. But it could also be the lemma, which is the base form of a word. Typically, a lemma is the same word, but without all the different inflections, all the different affixations, prefixes, suffixes, definitely relevant when processing morphologically rich language, like Arabic or Spanish, Hebrew, and so on. And there is also the type, which is simply referring to when we count every word only once, even if it appears more times in the text. So we count it only once. And sometimes it's just, we can use that to measure, how many unique words or lemmas we use in speech. LAWC, the Linguistic Inquiry and Word Count Tool, is a known psychometric analysis software which organizes words into categories that are relevant to some psychological conditions. It has in its dictionary about 2,300 words organized in about 80 different categories and subcategories. And those categories and words were picked carefully, manually, by a group of linguists and mental health professionals. So, for example, there are words that are related to biological processes, like body-related words, or social words, like family-related words, affect words, like positive words, negative words, and anxiety-related words, and so on. There are also functional words, not just content words. So words like, pronouns or determiners or prepositions, they're all of them are there. And then when you use LIWC, which is, by the way, pronounced look, the results of using LIWC look something like that. I mean, where you get like usage rate broken down into the different LIWC categories. And then people use these representations for finding correlations between specific signatures of word usage and some mental health disorders. That's a pretty simple analysis, but it's pretty common. Some other language characteristics that are considered in mental health analysis are more related to the structure of the language or the semantics. For example, the part of speech of the words, part of speech tags, like nouns and verbs, right? So they are very useful. So you can count how many verbs, how many nouns you mentioned in the text. And they help detecting problems related to poverty of speech, which might be a symptom for some mental health disorders. Detecting those part of speech tags is typically done, automatically using some machine learning algorithms. The syntax or the structure of the sentence might also be relevant for such analysis. Since for some of the disorders, it seems like the ability of forming a grammatically correct sentence is deteriorating, and using the syntax, we can detect that ahead of time. Different analysis can be done on the semantics level as well, like finding similarity between words as a tool for assessing the cohesiveness of the text. That's something I will show you next. It's exactly the things that I'm focusing on. And finally, the emotions and sentiment that are expressed by the speaker or writer are very important for depression-related disorders, for example. So they're used as well. Let's talk a little bit about depression. So depression, or the professional term is major depressive disorder, MDD, is one of the most widely recognized mental health disorder in the world. And it's one of the leading causes for suicide, and it affects about 1 out of 15 adult Americans. Now, early detection of signs of MDD and starting the proper treatment may help those people who are affected and ease their pain. The typical language-related symptoms of depression are related to negative or low valence emotions, as well as mentioning self-reference words like I, my, myself at a relatively high rate than usual. There are many studies that have been carried out by researchers using computational tools for detecting symptoms of depression or MDD. And here, only bringing here only 3 of them. And the bottom line of all those 3 and more, you can see that on the right column, is that they all connect depression with high rates of negative emotion words and also high rates of self-reference words or first-person pronouns. And it seems like, by the way, it seems like it's happening also in other languages and not just in English, and that's very interesting. Now, those specific words and some others are done on texts that are taken from the social media, like social media platforms, here specifically Reddit and Twitter, as you can see, because it's just relatively easy to get access to this type of data. And what you typically do is you search the media, the social media platforms for relevant users. So those are people who live with this, relevant mental health disorder that you care about for that particular study. And the most common way of finding them is by searching the media for expressions such as "I was diagnosed with depression," right? So things that are very similar to this expression, what we call self-reporting. And then manually we go over the retrieved users for filtering in only those cases that look authentic to us. Some of those studies also need a control group. That is people who don't experience the relevant mental health disorder in focus. So those people are typically chosen randomly, sometimes using some algorithms for matching their age or gender, and also sometimes to match the content of their posts. We want to match the content to the ones posted by the group of people who live with that mental health disorder that we care about. Now, it's not ideal, obviously, and there is usually no guarantee that those users who were retrieved as control, for example, are not experiencing depression, right? But that's something that we learned to live with, but it's definitely a caveat. Moving on to talking a little bit about schizophrenia, which is a mental health disorder affecting a bit less than 1% of the world adult population. And some of the major symptoms of schizophrenia involve speech disturbances, reflecting underlying disorders in the way of thinking, rather than just pure language impairment. So the clinical community called them thought disorders, and I'll explain a little bit more about them momentarily. Schizophrenia is also an active research area, and there are many works that were published about detecting schizophrenia using NLP, and those are just a few of them. The first work that you see here had discovered that people who live with schizophrenia mention more absolutist words in writing, by the way, not in speech. And absolutist words reflect a way of thinking in terms of totality. So it's like all or nothing kind of thinking, or black and white. And we're talking about words like nothing, completely, always, this kind of words. And the second word that you see here by Betty and others, they analyzed transcriptions of interviews with youth patients at a high risk of experiencing a mental health episode sometimes in their life. And they analyzed those interviews using some computational tools for predicting onsets of psychosis. If you're not familiar with this, psychosis is a serious deterioration of schizophrenia, and it is considered as a radical situation and typically requires immediate medical intervention. And they show that patients who are likely to experience psychosis in the future express themselves in a less cohesive way. And they found that using computational tools. That is, less cohesive way means that they derail from the main topic, right? The main message that they were trying to convey. And that was when speaking. And they also found that those people use less determiners in their language, like the, these, those, this kind of words, which reflects what professionals call poverty of speech. So that's another interesting symptoms that they found using such an analysis. And obviously there are more works that we can cover here. But let's focus a little bit more on schizophrenia now, because our work that I will show you soon, just some results from it, it's also going to be on schizophrenia. So as we said, one of the major symptoms of schizophrenia is what the clinical community calls thought disorder. And a thought disorder causes disorganized thinking, which can cause disorganized speech. And we're interested in that part. So I'm not a clinician, obviously. I'm a computer scientist, but as far as I understand, a thought disorder is something that is becoming more difficult to communicate your thoughts. But it's not a language impairment. As I said, it's a major symptom for schizophrenia, but it relates also to some other mental and even developmental disorders, such as the autism spectrum. And the research community distinguished between different types of thought disorders. And let me introduce only a few of them, specifically the ones that are relevant to our work. So derailment is a thought disorder that happens in free speech. So like speaking, and it happens when the speaker is jumping between different topics, essentially moving away from the main topic. Let's see an example, right? So it's a known example. I always liked geography. My last teacher in that subject was Professor August A. He was a man with black eyes. I also like black eyes. There are also blue and gray eyes and other sorts too, right? So it clearly can be seen that, it starts good, but then moves to, completely not interesting, not the main topic. Could be interesting. Tangentiality, that's another thought disorder, which is very similar to derailment. And it happens the same way when the patient or the person moves away from the main topic when trying to answer a question rather than just free speech. So here's an example. How have you been feeling today? Well, in myself, I have been okay with what the prices in the shops being what they are, and my flat is just around the corner. I keep a watch for the arbiters most of the time since it's just around the corner. There is not all that much to do otherwise. So that's a good example. It's a real example of tangentiality. So there is a question. It starts good, but then immediately it moves to a completely off topic. Derailment and tangentiality are related, as we said, and in fact, they're very similar in practice. Both reflect what we call loose associations, and it's when the speaker produces related or associated words or expressions during the conversation, but unfortunately they are out of context completely, sometimes similar to what you actually wanted to convey. So I'll give you some examples soon. And loose association is a positive thought disorder as opposed to negative thought disorder. Negative thought disorders describe the lack of some normal verbal functions, and positive thought disorders refer to the presence of some abnormal functions. So this is a positive thought disorder. Another positive thought disorder relates to single word generation problems. So only one word in the text. So the text is okay, but one word is abnormal, and so it happens. When they try to kind of change a known word or completely invent a new word, and then use it in context. So this is a known example, a real example. So I sort of broke the whole thing up. So I give you a hint for what it should be, probably, right? But that's a single word abnormality. Here is another example. This is what we call neologism. That's also a single word abnormality. It can get very creative, right? So she started talking marriage and he started Batmobiling. So that's a single word that was invented. It's like a metaphoric neologism. It's very, very creative. And by the way, these kind of thought disorders is also connected with creative people and not people who suffer from thought disorders. So sometimes it's very difficult to distinguish between those two groups. And sometimes it can get very idiosyncratic, not very creative. For example, here, right? And they wave their things on the floor in the bathroom. So that's a known example, and it's known to be leave. Probably that was so wave instead of leave, but it's very difficult to understand that, and there are more complicated examples that I could show you. And there are some grammatical mistakes as well. Usually, agreement mistakes, like here. What does cows do, right? And we're talking about native English speakers or native any other language speakers. And finally, in severe cases, it can get to completely unintelligible or incomprehensible speech due to several grammatical mistakes, many bad semantic choices, and it's what we refer to as word salad. But it's very radical what I'm showing now. So you can check out later and this specific example. I'll just start reading it, but I will not complete. So, and again, this is a known example. They're destroying too much oil just to make soap. if we need soap, when you can jump into a pool of water, and then when you go to buy your gasoline, my folks always thought they should get popped by the best thing to get in motor oil. So you can see that it's getting very, very problematic. So it's what we call word salad. How those thought disorders can be detected today? Mostly by interviews. There are some questionnaires sometimes, but it's mostly by interviews. I mean, speaking with the person, the patient, asking questions, hearing him or her speaking may give the clinicians and the therapists some indications about their condition. But detecting all those disorders might be challenging because, I mean, there are many subtleties and it's very subjective, and typically it requires a lot of experience in order to succeed in this particular task. So let me now introduce a work that I've been working on recently with these great people mentioned here. And I mean, we're still working on this, but we have recently published some of the results, so you can take a look later, but soon we will publish more results. So in this work, we propose a computational approach for using natural language processing for extracting some features from transcribed speech, indicating the existing of specific types of thought disorders. Some of them I already showed you now, and then use these features to train machine learning classifier to detect schizophrenia. So I'm not going to go into too many details because we are running out of time, and you can always go to the paper if you want to get more details, but I just want to give you the overall view. So where did we take the data from? We collaborated, we're still collaborating with a mental health center in Israel. This is where I'm based, and it's called Be'er Yaakov Mental Health Center. And overall, we were able to collect speech samples from 60 inpatients. They are all officially diagnosed with schizophrenia, and most of them are in remission. But the results I will show you now are based only on 24 of them. We already have some results for the larger group, but it's still not officially released. For our control group, we wanted to compare whatever we found. We wanted to compare that to people who don't live with schizophrenia. So we simply collected, speech samples from a random demographically equivalent group of people. We just put up an ad on Facebook, and we recruited people for this experiment, for this trial. So what we did is that we interviewed each one of the participants, and in order to make them talk about more or less the same things, we created a structured questionnaire with 18 different questions. In fact, for the 14 first questions are just images. They call the thematic appreciation test, or TAT images, for which we ask the participants to describe what they see in the picture in free text. And we have all the details about the structure of the interview, and all the statistics, that descriptive statistics that we could take from it. It's all in the paper. And then there were 4 more questions about life in general and planning for the future. And of course, the entire operation was approved by IRB. It's very important to say that, and all the ethical approvals were granted. It takes a lot of time. Now, the interviews were recorded and then transcribed manually a couple of times to make sure that there are no mistakes. And then we processed the transcriptions using some natural language processing tools. I'll show you one of them in the next slide. And all participants, just make sure to mention that all participants are native Hebrew speakers. We had other speakers too, other participants too, but we had to exclude them from the trial, since we wanted to focus only on native speakers. This is just an example of the images, the TAT images. Those are known images that we used for asking the participants to describe what they see in the image, and then we process the transcribed speech. Let's talk about derailment and the features we use to represent it in our case. So what we did is pretty simple. We wanted to check if the speaker is jumping between different topics, very often. So we calculated a score for every word in the text, reflecting the similarity of that word to the K following words. Now, K is just a number, and we use different values for that number. What you see here in the picture, this is just an example. If you look at the second word in red here, so we calculate the cosine similarity between the embeddings of that word. So if you think about fast text or something, right, or glove, and then the embeddings of the, say 3 words here. So word 3, 4, and 5. So here in this particular example, K equals 3. And then we take the average of those cosine similarities. We have 3 cosine similarities. We just take the average and we use that to represent the score, the, let's say, derailment score of word number 2 in this example. And then we do that for every word, as we said. So we have all the scores for every word, and we take their average, and that score represents, the derailment level of this entire text. So in other words, a relatively high score is assigned to a text with relatively, high rate of similar words. So the text is more cohesive, and probably there is less derailment in this text. To show you how this score is distributed between the participants, we average together all the scores of the patients group and the control group. So only one number per group. And we try different values of K, which is, again, the number of words we consider when we calculate the cosine similarity. And you can see some results. The figure on the left here shows an average score we calculate for every group. Patients are represented by the dashed line, controls are represented by the plain line. And the score is represented by the y-axis. The x-axis represents the different values of K that we used. And we can see that overall the text becomes less cohesive when we use a larger value of K. That makes sense. But while it seems like there is a difference between the two groups, it looks like controls speak more cohesively. But it seems like, the difference is actually insignificant. But when we remove, those unimportant words from the text, those that don't carry any meaningful meaning, we get a different picture. And for us, important words are considered to be nouns, verbs, adjectives, adverbs, and not those functional words. So when we remove those functional words, you can see a larger difference between the two groups, and that is measured to be statistically significant. We extracted a few more features, but we are running out of time. So I'll just say that, despite the relatively small number of participants, we decided to train a machine learning classifier that uses those features, and then evaluate that classifier with cross-validation tenfold. And here are some results using some, popular traditional machine learning algorithms that we tried. The best accuracy here is about 81%. And obviously it's a small data set, but it still can give us some, directional results and, future directions. We already have a larger sample, and soon we'll publish more results. By the way, when we tried this same thing on social media, we couldn't replicate the same result. And it makes sense because probably, it's not surprising, right? That derailment and incoherence-related thought disorder are typically more pronounced in speech. So to conclude this session, I would say that there are many ways for using natural language processing to diagnose mental health disorders. I think it's just the beginning. One of the main challenges obviously remains access to data. It's difficult to get access to speech samples of people who live with mental health disorder. But I believe that, the recent developments with the pandemic, when there is a dramatic increase in the number of complaints about mental health conditions, hospitals and mental health centers are more open to share data to enable new directions of research in mental health using AI. Then that's what I had for you today. Thank you so much for staying. Happy to answer any questions. Thank you.